Hi, today we have come to the last session of Give a Chemical Test to differentiate between two chemicals. We will learn how to differentiate between two acids and then two alkalis. Before we start, let us have a discussion about acids related to 10th standard syllabus. We have three acids in the syllabus, which are hydrochloric acid, sulfuric acid, and nitric acid. Both dilute and concentrated properties are discussed. All dilute and concentrated acids are colorless. Dilute acids normally exhibit typical acidic properties. Concentrated sulfuric acid and nitric acid exhibit oxidizing property. Concentrated sulfuric acid exhibits non-volatile and dehydrating properties. Concentrated hydrochloric acid is a reducing agent. So the question may be, any two dilute acids, a dilute acid with one concentrated acid or two concentrated acids, but a strong question is one in which both the acids exhibit at least one common chemical property. For example, both dilute hydrochloric acid and dilute sulfuric acid are colorless and exhibit typical acidic properties. Both concentrated sulfuric acid and concentrated nitric acid are colorless and are oxidizing agents. So the most probable questions are: give a chemical test to differentiate between dilute hydrochloric acid and dilute sulfuric acid, or concentrated sulfuric acid and concentrated nitric acid. However, any other acids may come as a question. How to select an appropriate reagent. Although all chemical tests can differentiate between two, select a chemical test which is uncommon to both the acids, that is, positive to one and negative to another. So let us know the various chemical tests for both dilute and concentrated acids from which we have to choose the best suited. B. Chemical test for dilute hydrochloric acid is the silver nitrate test. On reaction with dilute hydrochloric acid, a white precipitate of silver 1 chloride is formed, which is soluble in excess of ammonium hydroxide. Another chemical test for dilute hydrochloric acid is the lead nitrate solution test. On reaction with dilute hydrochloric acid, a white precipitate of lead 2 chloride is formed, which is soluble in hot water. The chemical test for concentrated hydrochloric acid is the reaction with manganese dioxide. On reaction, a greenish-yellow gas, chlorine, is formed. Other oxidizing agents like lead-2 oxide, red lead, potassium dichromate, or potassium permanganate can be used, as all of them release the same greenish-yellow gas of chlorine on reaction with concentrated hydrochloric acid. The chemical test for dilute nitric acid is the brown ring test. A brown ring is formed in between the junction of the two liquids. The chemical test for concentrated nitric acid is its thermal decomposition. Reddish-brown fumes of nitrogen dioxide gas are formed. Another chemical test for concentrated nitric acid is its heating with copper turnings. A blue copper nitrate solution is formed along with evolution of reddish-brown fumes of nitrogen dioxide gas. B. Chemical test for dilute sulfuric acid is the barium chloride or barium nitrate solution test. A white precipitate of barium sulfate is formed, which is insoluble in all dilute acids. Another chemical test for dilute sulfuric acid is its reaction with lead nitrate solution. A white precipitate of lead-2 sulfate is formed, which is insoluble in all dilute acids. The chemical test for concentrated sulfuric acid is its reaction with copper turnings. Concentrated sulfuric acid reacts with copper to give blue-colored copper-2 sulfate solution. Example 1 is: give a chemical test to differentiate between concentrated sulfuric acid and concentrated nitric acid. Analysis: both the acids are oxidizing agents and react with copper to give a blue copper-2 nitrate solution. In the case of concentrated nitric acid, reddish-brown fumes of nitrogen dioxide gas are formed, and in the case of concentrated sulfuric acid, a colorless sulfur dioxide gas is formed. So the agent is copper, and hence the difference in the color of the gases is to be focused. Answer is: copper turnings are added to the two acids and then heated. A blue-colored solution is formed. In both the cases, the case in which reddish-brown fumes are seen is concentrated nitric acid, and the case in which no colored fumes are seen is concentrated sulfuric acid. Example 2 is: give a chemical test to differentiate between dilute sulfuric acid and dilute hydrochloric acid. Analysis: if we focus on the chemical test of dilute sulfuric acid, we would have to use barium chloride solution, because with barium chloride solution, dilute sulfuric acid gives a white precipitate of barium sulfate, but barium chloride does not react with dilute hydrochloric acid. So the agent is barium chloride solution, and the focus should be on the white precipitate of barium sulfate. Answer is: barium chloride solution is added to the two dilute acids. The case in which a white precipitate of barium sulfate is formed is dilute sulfuric acid, and a case in which no precipitate is formed is dilute hydrochloric acid. Now let us differentiate between two alkalis. We have sodium hydroxide, potassium hydroxide, and ammonium hydroxide. Out of the above three, the reactivity of sodium hydroxide and potassium hydroxide with other chemicals is similar. Now let us differentiate between two alkalis. We are getting only one case, that is sodium hydroxide or potassium hydroxide with ammonium hydroxide. To differentiate between two alkalis, we have to consider their difference in chemical properties. Amphoteric metals, oxides and hydroxides react with sodium hydroxide and potassium hydroxide, but not with ammonium hydroxide. Calcium salts do not form any precipitate with ammonium hydroxide, but they form precipitate with sodium hydroxide and potassium hydroxide. How to select a reagent? Select a chemical test which is uncommon to both the alkalis, that is a positive test to one and negative test to other. Example 1 is: give a chemical test to differentiate between sodium hydroxide and ammonium hydroxide. The answer would be calcium nitrate solution is added to both the samples of alkalis respectively. The case in which a precipitate is formed is sodium hydroxide, and the other in which no precipitate is seen is ammonium hydroxide. Hope you liked the video. Do not forget to subscribe to our channel in case you haven't. Press the bell icon for further notifications of new videos. Thank you for watching.